Now let's create block reference using 2D road cross-section drawings. First, open 2D cross-section CAD file. For this training, let's create block reference of cross-sections from station 496 plus 762.5 to station 497 plus 100. Let's start creating block reference from station 496 plus 762.5. From the 2D cross-section drawing, let's decide which surface we need to create the 3D drawing. In this case, we need to create 3D drawing for soil cut and fill, so we choose the pink line as top of our 3D design surface. Right now, pink lines are separated polylines. So before converting it to block reference, let's combine it to become one polyline. To do so, use join command. Then click all the pink polylines to be joined. And then press enter. Polylines has been successfully joined. Next, let's convert polyline cross-section to block reference. Go to Insert. Then Block. And click Create. In the block definition window, specify station name. Next, let's specify pick point from the drawing. Since our road centerline elevation follows top of the road pavement, so we select top of pavement as pick point. Click Pick Point Select button. Then select pick point in the drawing as shown. And press enter in your keyboard. In Objects section, click Select Objects button to select polyline to be converted to block reference as shown. In this case, click pink colored polylines to select. Then press enter. In Behavior section, make sure that the Allow Exploding box is checked, then click OK. Now check the properties of the block reference to confirm if the polyline cross-section is successfully converted to block reference cross-section. To do that, select the cross-section, then right-click in the workspace, then find and select Properties. Here you should see block reference as shown. Now, perform the same procedure to create block reference cross-section for succeeding stations. Station 496 plus 775. To station 497 plus 100. Now let's create road center feature line. First, let's open Plan View Drawing. In this training, we need to create road center feature line from station 496 plus 762.5. To station 497 plus 100. Now let's convert alignment drawing to feature line. Go to Home ribbon. Under Create Design panel, click Feature Line. Choose a Create Feature Lines from Alignment function. In the workspace, click to select the alignment you want to convert to feature line as shown. In the Create Feature Lines from Alignment window, follow the settings as shown and then click OK. When the Weed Vertices window appears, click OK. Now feature line is made. Next, let's trim road feature line. Locate station 496 plus 762.5. Then type brake feature command. Click on the feature line in the location before station 496 plus 762.5 as shown. And then, click exactly on the location of station 496 plus 762.50 as shown. After breaking the feature line at station 496 plus 762.5, delete the excess feature line before station 496 plus 762.5 as shown. Now, using the same procedure as before, let's break feature line at station 497 plus 100. Find station 497 plus 100. Then type brake feature command. Click on the feature line in the location after the station 497 plus 100 as shown. Next, click exactly on the location of station 497 plus 100. After breaking the feature line at station 497 plus 100, delete the excess feature line as shown. Now that we have the feature line from station 496 plus 762.5 to station 497 plus 100. Next, let's hide the unnecessary drawing objects. Click feature line, and then click alignment label to select. While feature line and alignment label are selected, type isolate, then press enter in your keyboard. Save your work and then proceed to the next step. Now let's edit and input the correct elevation information in every stations. In this training, let's get the elevation data from 2D cross-section drawings. With that said, let's copy the cross-section drawings and paste near the road center feature line drawing as shown. Now let's put elevation points in every 12.5 meters stations of the road center feature line. To do that, click Insert Elevation Point function in the Elevation Editor window. Then hover and click exactly in the location of the target station. In this case, station 496 plus 775. Once Insert PVI window appears, just click OK. Do the same procedure to all succeeding stations until station 497 plus 087.50 is done. After adding elevation points in all the stations, let's input the correct elevation of each station. In the elevation editor window, we can edit the elevations in every station of the feature line. In this case, station 496 plus 762.5 is equivalent to station 0 plus 000 in our road center feature line. Now check the elevation of station 496 plus 762.5 from the 2D cross-section drawing. In this case, elevation is 562.261 meters. Next, input elevation 562.261 meters to station 0 plus 000 in elevation editor window. Next, check the elevation of station 497 plus 775.00 from the 2D cross-section drawing. In this case, elevation is 562.731 meters. Input this elevation to station 0 plus 012.5 in elevation editor window, since station 0 plus 012.5 is equivalent to station 497 plus 775. In the elevation editor window, you can see that station 0 plus 009.89 has 0 elevation and 2D cross-section does not show its elevation. To get the elevation, let's assume that the slope from station 0 plus 000 to station 0 plus 012.5 is constant. To calculate the elevation, left-click station 0 plus 000, and while it's highlighted with blue, press and hold Ctrl and Shift button in your keyboard and left-click station 0 plus 012.5 as shown. Once all stations are selected, click the Flatten Grade or Elevations button. When Flatten window appears, select Constant Grade and then click OK. Continue working until you fill in all the elevations of the feature line as shown. Now let's create dummy road assembly and subassembly. To do so, go to Home ribbon. Then under Create Design panel, click Assembly. Then choose Create Assembly. In the Create Assembly window, type assembly name. And then click OK. And then click in the workspace as shown. Next, open Tool Palettes. Under Basic tab, click Basic Lane. Then click on the right and left side of the assembly to create the lanes as shown. Now let's create Road Corridor. Under Home ribbon and Create Designs panel, click Corridor. Next, select Feature Line. Then type feature line name and click OK. In the Create Corridor window, set assembly to the assembly you just created. In my case, I set it to Temporary Road Assembly as shown. Then click OK. When baseline and region parameters window appear, set frequency of assemblies to 12.5 meters as shown. Next, click Apply. Click Rebuild the corridor. And then click OK. Now road corridor has been created. Now let's edit road corridor cross sections. To do that, select Road Corridor in the workspace. On the Modify Corridor section panel, click the drop-down button of Section Editor as shown. Select Edit Viewport Configuration. On the Viewport Configuration window, set Layout to 2 horizontal. Set Viewport 1 to Plan. And set Viewport 2 to Section. Then click OK. Now click Section Editor button. And display should change as shown. On the Station Selection panel, select Station 0 plus 000 as shown. Remember that Station 0 plus 000 is equivalent to Station 496 plus 762.5. Now click on the bottom screen. The button screen is the corridor section viewport. Let's attach the block reference cross section in here. To do so, go to Insert Ribbon. Under Block panel, click Insert. Then Recent Blocks. Blocks window will appear in the right side of the screen. In the Blocks window, select the desired cross-section. In this case, let's select cross-section of Station 496 plus 762.5. When this window appears, select Don't Redefine option. Now go to Section Viewport. Click the mouse cursor exactly in the center of the circle as shown. Now, cross-section of Station 496 plus 762.5 has been attached. To attach the next block, click the Section Editor ribbon as shown. On the Station Selection panel, select Station 0 plus 012.5 as shown. Station 0 plus 012.5 is equivalent to Station 496 plus 775. Now click on the bottom screen. In the Blocks window, select the cross-section of Station 496 plus 775. When this window appears, select Don't Redefine option. Now go to Section Viewport. Click the mouse cursor exactly in the center of the circle as shown. Now cross-section of station 496 plus 775 has been attached. Perform the same procedure to attach all block reference cross-sections for the succeeding stations. Once cross-section of station 497 plus 100 is completed, click Close as shown. Here you can see that the cross-sections have been completely attached. Finally, let's create 3D tin surface. First, let's isolate the block reference cross-sections. To do that, select all the cross-sections as shown. Once all cross-sections are selected, type Isolate command. Then press Enter in your keyboard. Right now, the cross-sections are still block reference. We need to convert it to polylines. To do so, type Explode command. Then select all the cross-sections as shown. Then press Enter in your keyboard. Now cross-sections are converted to polyline. Next step is to connect the vertices of the cross-sections. To do that, rotate the drawing as shown. Use 3D Poly command. Then, draw 3D polylines connecting the vertices of the cross-section as shown. Proceed to 4-minute 35 seconds of this video to see the completed drawing. After completely connecting the vertices of the cross sections, let's now create tin surface. Open Tool Space. Then click Prospector tab. Left-click Surface. Then choose Create Surface. In the Create Surface window, input surface name. And then click OK. On the tool space, click Expand button near Surface. Next, click Expand button near the surface name as shown. Then, click Expand button near Definition as shown. Left-click Break Lines and select Add. When Add Break Lines window after deleting all unnecessary lines from the tin surface. Now, select all the 3D drawing as shown. Then, press Enter in your keyboard. While drawing is in top view, select the tin surface as shown. Open Surface Properties. Then select Edit Surface Style. In the Surface Style window, turn on triangles, turn off major and minor contour as shown. Then click Apply and then OK. Using Edit Surface function, delete unnecessary lines. To see the correct design boundary, send tin surface behind the polylines as shown. Next, select the tin surface. Under Edit Surface button, select Delete Line function. Then select unnecessary lines as shown. Then press Enter in your keyboard to delete the selected lines. Repeat the same procedure to delete all necessary objects as shown. After deleting all unnecessary lines from the tin surface, use Isolate command to hide unnecessary polylines. You can check tin surface condition using Object Viewer as shown. Once you are satisfied with the 3D tin data, you can export it as DXF file as shown.